Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying straight lines lecture 5. So we'll be starting our lecture with general form of line and we represent the general form with ax plus by plus c equals to 5 equals to 0. So until now we have studied five different forms of line, but this one is the general form. Now what I'll do, I'll try to convert this equation into slope intercept form, that was y equals to mx plus c, to get some information from there, and the other one would be x by a plus y by b equals to 1. So basically the intercept form, right? So let's do the first one, y equals to mx plus c. So for that, by equals to minus ax minus c equals to, sorry, minus c only, not equals to 0, just minus c, right? And y would become minus a by b times x minus c by b. Let's call this as k. Now if I compare this one with y equals to mx plus c, I can see that m equals to minus a by b, right? Now what can we conclude from this one? We can conclude that if a general form of equation is given, let's say we have been given 3x plus 4y plus 5 equals to 0. In that case, slope, we can find out the slope of this equation directly by doing minus times coefficient of x divided by coefficient of y. So minus 3 by 4 is the slope of this equation. We can do that very easily based on this conclusion, right? Now let's convert this equation into the other format. For that, ax plus by equals to minus c, and what I'll be getting, x divided by minus c by a plus y divided by minus c by b equals to 1. So the intercepts will be minus c by a and minus c by b. So this is how you have to convert this format into intercept format and find out the intercepts. So plotting intercept form is very easy because you know the intercept and now you have just 2 points. You can find out, you can just plot the line, or if you want to find out the equation as well, if you know the intercepts, then you know this point, you know this point, basically you know 2 points, you know the slope and you know 1 point, you can find out the equation. So writing the general form of line into the intercept form is very useful for these kind of informations. Now let's talk about angle between two lines. And we have studied a similar kind of concept in AOD when we talked about angle between two curves. But in that case, what we did, we calculated the tangents at this particular point, and then we calculate the angle between these two tangents. But in this case, it's not that difficult. So let's say we have these coordinate axes, and let's say these are two lines. So this has slope m1 and this has slope m2. This is forming angle, let's say A, and this is forming angle, let's say B. This m2 is this line with slope m2 is forming angle B. This line with slope m1 is forming angle A. Now the difference, let's call it as theta. Now with basic trigonometry, we can say that tan theta would be tan of A minus B, right? And that would be tan A minus tan B divided by 1 plus tan A tan B, right? That would give me, let's say this is A line, this is B line. So m2 minus m1 divided by 1 plus m2 m1. So this is our slope. This also we derived in the AOD. Now we also studied that whenever we are reporting angle between two curves or two lines, we always report the acute angle. We don't report the obtuse angle, right? But we can have the case where, let's say this is our line A and this is our line B, and this angle is A and this angle is B. So over here we can clearly see that the angle theta is obtuse. In such a case, this expression would become negative. So to make it positive, to make it acute, what I'll be doing, I'll be doing tan theta equals to modulus of m2 minus m1 divided by 1 plus m2 m1. Right? Because we always have to report the acute angle. So if this is theta, that is obtuse, we have to report pi minus theta. So mathematically that would look like tan theta equals to modulus of m2 minus m1 divided by 1 plus m1 m2, right? Now let's look at one question. The acute angle between two lines is pi by 4 and slope of one of them is 1 by 2. Find the slope of the other line. So one line is being given is, and m equals to 1 by 2. Let's call it as m1. And now we have to find one more line where slope is, where angle between these two lines is basically pi by 4. Now we haven't given that it's on the right side or on the left side. So it can be either over here or it can be either over here. So let's call it as a variable line, let's say on this side, and we'll get the two answers because of the modulus. So let's take on one side as of now, and we'll get the two answers eventually. So this has m2 as a slope, and this angle is pi by 4. So tan theta equals to tan of pi by 4, and that would be modulus of m2 minus m1 divided by 1 plus m1 m2, right? So tan pi by 4 is 1. So 1 equals to modulus of m2 minus 1 by 2 divided by 1 plus 1 by 2 m2, right? Now this modulus can open in two manners with plus or minus sign, right? So let's take the plus case. That would give me m2 minus 1 by 2 equals to 1 plus 1 by 2 m2, right? So that would become m2 by 2 equals to 3 by 2. That would give me m2 equals to 3. Similarly, if you try to calculate the other value, that would come out to be minus 1 by 3. How do I know that? Because the other value would be towards here. That would be pi by 4. And we know that when two lines are perpendicular to each other, if this is pi by 4 and this is also pi by 4, and we calculated this value as 3, then this is bound to be minus 1 by 3, because in case of perpendicular lines, the product of slopes is minus 1. So even if you try to calculate with the minus sign over here, then also you'll get m2 as minus 1, minus 1 by 3. And also with common sense, since because this is pi by 4 and this is pi by 4, so this entire angle is pi by 2. In case of perpendicular lines, the product of slopes is minus 1. So if this was 3, so this was bound to be minus 1 by 3, right? Now let's look at one more question. A straight line L through the point 3 comma minus 2 is inclined at an angle 60 degree to the line 3x root 3x plus y equals to 1. If L also intersects the x-axis, then the equation of line L is. So that is again just a replica with some more information as compared to the previous question, right? So we have been given one line, that is root 3x plus y equals to 1. This is one line. Now we can, with the help of our general equation, what we can say, slope of this line, let's say this line is L1, so mL1, that would be minus of coefficient of x, that would be minus root 3, divided by coefficient of y, that is 1. So basically not mL1, let's call it as m1 only. m1 equals to minus root 3 only. Okay, now there is one more line which is passing through 3 comma minus 2. Let's say 3 comma minus 2 is somewhere over here, 3 comma minus 2, and this line is passing through there, and that is inclined at an angle 60. And again, we can have two cases over here, just like the previous question. If 60 degree, if for this particular side 60 degrees is over here, so for the other case 60 degree would be something of this sort, right? But let's take just one case and we'll get the two answers with the help of modulus only, right? So let's say this has slope m2. Now we know that tan 60 degree equals to m2 minus m1 divided by 1 plus m1 m2. So tan 60 degree would be root 3. That would be m2 minus m1. So m2 minus m1 is root 3 minus root 3, and 1 minus root 3 m2, right? So if I open the modulus with the positive sign, I'll be getting root 3 times 1 minus root 3 m2 equals to m2 plus root 3. So that would be root 3 minus 3 m2 equals to m2 plus root 3. So this gets cancelled out. So basically m2 equals to 0 over here. Now, but that is not possible. Why? Because L is also intersecting the x-axis. In case of slope is equals to 0 and this line is passing through 3 comma minus 2, in that case it won't be intersecting with x-axis. So that's why this slope would be rejected. Now you'll have to take the other case with minus root 3 and you'll find the answer with that one, right? You can do that calculation afterwards. Now let us talk about angle between two lines, two special cases, right? So the first case is parallel lines. In that case, m1 equals to m2. So in case of parallel lines, the angle between the two lines would be 0. So in that case, that formula tan theta equals to m1 minus m2 divided by 1 plus m1 m2, that should be 0, right? Because in this case m1 equals to m2, and that would give me tan theta equals to 0. So basically theta equals to 0. In case of parallel lines, theta equals to 0 between two lines, and m1 equals to m2. So if the first line equation is given like ax plus by plus c equals to 0, the second line would automatically be ax plus by plus k, some parameter or constant, that is equals to 0, right? So this was about parallel lines. Now if we talk about the perpendicular lines, in that case tan theta equals to m1 minus m2 divided by 1 plus m1, m2. Now, if these two lines are perpendicular, so basically angle between them should be pi by 2. So tan theta would be infinity, yeah, or approaching infinity, right? So that would be only possible if this becomes close to 0, right? So that would mean that m1, m2 equals to -1, right? So if m1, m2 equals to -1, in that case, tan theta would become pi by 2. Tan theta would become infinity and theta would become pi by 2, right? Now, in case the line 1 is given as ax plus by plus c equals to 0. So basically, m over here would be minus times a by b, right? So basically, the slope of the other equation, perpendicular equation, would be minus 1 by m. That would be b by a. So you can clearly see that over here, the slope is b by a and plus some k, where k is a constant or a parameter, which you can find with the given other given conditions. So if this is the line of an equation and if the slopes are perpendicular to each other or both lines are perpendicular to each other, in that case, you can directly write this way. Now let's talk about one example. Let PS be the median of a triangle with vertices P 2, 2, Q 6, -1 and R 7, 3. The equation of the line passing through 1, -1 and parallel to PS is. So we have been given one triangle P, Q, R, and we are dropping this median over here. So P is 2, 2, Q is 6, -1, R is 7, 3, right? Now with the help of midpoint theorem, we can find out the coordinates of S as well. So that would be 6 plus 7 by 2, that would be 13 by 2. And -1 plus 3 whole by 2, that would be 1 only, because this is -1 plus 3, that would become 2. 2 by 2 is 1. And these two portions are actually equal because of the median. Now we have to find out the equation of line passing through 1, 1 and parallel to PS. So basically we have to find out the slope of this one and we have to find out the equation of this particular line which is parallel to PS. So this will also be having a slope m. So for m, we'll be calculating from here. So m would be y2 minus y1, that would be 2 minus 1 divided by x2 minus x1, that would be 2 minus 13 by 2. So that would give me 1 upon this would become minus 9 by 2, minus 9 by 2. So 2 goes over here. So m equals to minus 2 by 9 for this new equation. Now this also passes through 1 comma minus 1. So basically we have been given 1 point 1 comma minus 1. We know the slope of this equation. Can we write the equation of this line? Yes. So that would be y minus y1, that would be y plus 1 equals to x minus m times x minus x1, that would be x minus 1. So this would become 9y plus 9 equals to minus 2x plus 2. So that would give me 9y plus 2x plus 7. This is 2x equals to 0. So D is the correct answer. Now let's talk about finding the circumcenters and orthocenters. So initially we talked about, in previous lectures, we talked about finding the incenter, finding the centroid, but now we are talking about circumcenters and orthocenters. So how do we do that? Let's say this is our triangle A, B, C, and the coordinates are x1, y1, x2, y2, and x3, y3. Now, with the help of definition of circumcenter, we know that circumcenter is the point of intersection of perpendicular bisectors of all the sides. So what I'll do, I'll draw one perpendicular bisector of this side BC, and I'll draw one perpendicular bisector of this side AC. With the help of these two lines, with the help of these two perpendicular bisectors, we can find out the point circumcenter. We could have drawn the third one as well, but that won't make sense because we can find out the point with the help of two equations only, right? So now let's call it as L1 and let's call it as L2. And let's try to find out the equation of L1 and L2. So with the help of midpoint theorem, since this is perpendicular and it's also bisector, so with the help of midpoint theorem, we can find out the coordinate of this point. That would be x2 plus x3 by 2 and y2 plus y3 by 2, right? Similarly, this point would be x1 plus x3 by 2, y1 plus y3 by 2, right? Now we have got the coordinates of these 2 points. Now how to find out the equation of both L1 and L2? In that case, what we'll be doing? We know the slope of MAC. We know the slope MAC. That would be y1 minus y3 divided by x1 minus x3. Now this line is perpendicular to AC. So that would be minus 1 upon MAC. Slope of this L1, that would be ML1. Now we know the slope, we know the point, we can find out the equation. Similarly, over here, we can find out the slope of BC, and with the help of slope of BC, we can find out the slope of L2 with minus 1 by MBC, and that would give me the slope of ML2. And we know the point, this particular point with the help of midpoint theorem, and we can find out the equation of this point. Now, when we get the equation of both L1 and L2, in that case, we have to solve them simultaneously to find out this point circumcenter, right? Now let us talk about the orthocenter. That is a little easier as compared to circumcenter. Circumcenter becomes quite lengthy for the calculation part. Let's say this is A, this is B, and this is C. Let's drop two perpendiculars. So this point is, let's say, D, and this point is, let's say, E. Now this is x1, y1, this is x2, y2, this is x3, y3. Now MBC over here would be y3 minus y2 divided by x3 minus x2. Similarly, MAC would be y3 minus y1 divided by x3 minus x1, right? Now slope of this perpendicular would be minus 1 by MAC. So let's call this as MBC, and that would be minus 1 upon MAC. Similarly, MAD would be minus 1 upon MBC, right? Now we know the slope, and also AD passes through this point. We don't have to calculate D point. We don't have to calculate E point over there because we know A and B coordinates. So we know one point, we know the slope of AD, and we can find out the equation. Similarly, we know point B, we know the slope of BE, and we can find out the, sorry, this was BE, not BC. We know the slope of BE, we know the point B, and we can find out the equation of BE. And while simultaneously solving BE and AD, then we can find out the point orthocenter O, right? Now let's do one example for the same. Find the circumcenter of the triangle whose vertices are 1, 2, 3, minus 4, and 5, minus 6. So we have been given one triangle A, B, and C. Let's say A is 1, 2, B is 3, minus 4, and C is 5, minus 6. Now let's draw two perpendicular bisectors. So this is perpendicular, this is perpendicular, this is equal, this is equal. So let's say this point is D, and this line is L1, and this line is L2. Let's say this point is E. Now the coordinates of point D would be this plus this by 2. So 3 plus 5 by 2, that would be 4. And minus 4 minus 6 by 2, that would be minus 5. And similarly for E, it would be 1 plus 5 by 2, that would be 3. And the other point would be 2 minus 6 by 2, that would be minus 2. So we have got the points. Now MAC would be 2 minus 6 divided by 1 minus 5, that would be minus 2. So basically slope of L2, that would be minus 1 by MAC, that would give me 1 by 2. Similarly, MBC would be minus 4 minus of minus 6 divided by 3 minus 5, that would give me minus 1, right? And therefore ML1 would be minus 1 upon MBC, that would be 1. Now we know the slope of L1, we know the slope of L2. Let's try to find out the equation of L1. So for L1, we know the point. So that would give me y plus 5 times y plus 5 equals to ML1, that is 1 times x minus 4. This would give me y plus 5 equals to x minus 4. So this would become y minus x plus 9 equals to 0. Now for L2, we'll be getting y plus 2 equals to slope is 1 by 2 times x minus 3. This would become 2y plus 4 equals to x minus 3. That would give me 2y minus x plus 7 equals to 0. So these are the two equations which we have got for the perpendicular bisectors. Now we have to solve both of them. It has become a little messy over here. So if I subtract both of them, what I'll be getting, if I, this is, let's say this is 1, this is 2. If I subtract 2 from 1, I'll be getting y minus 2 equals to 0. So y equals to 2. And if you put this value over here, you'll be getting x equals to 11. So C is the correct answer. Now let's talk about position of a point with respect to a line. So let's say we have a line L1 over here. Let's say this point is x1 and y1. Now if I go vertically upwards and I take a point x1 and y2, and if I go vertically downwards, if I take a point x1 and y3. So I'm going vertically up and vertically down to keep the x value as constant because I want to demonstrate one thing. Let's say this line equation is ax plus by plus c equals to 0. Now since this point x1 y1 is lying on this equation, so we can safely say that ax1 plus by1 plus c equals to 0, right? Now let's assume that b is greater than 0 for one particular case. B is greater than 0. Now if I plug in this value in this equation of line, I'll be getting ax1 plus by2 plus c. Now, what would be the sign of this particular equation? That would be greater than 0 because b is greater than 0 and y1, y2 is greater than y1 and this coefficient b is positive. So, if this is positive, this is bigger than this one and this was 0. So, this would become greater than 0, right? Similarly, if I plug in this point in this equation, I'll be getting ax1 plus by3 plus c, and that would be less than 0 because y3 is less than y1, y3 is less than y1 and this was 0, so this should be less than 0. So main point to understand with this one is if two points are there on the opposite side of line, so this point is over here on the left hand side of the line and this point is over here on the right hand side of the line, and these points, if I plug in the value in the equation of line, in that case I'll be getting opposite signs. It in case of b less than 0, I'll be getting this as less than 0 and this as greater than 0. So that actually depends on the coefficients of line, but the main point is if a point is over here and if a point is over here, basically on the opposite sides, in that case if I plug this point in the line, if I plug this point in the line, both will have the opposite sign. That should be remembered, right? And to understand this concept, let's try to solve this question. If a comma a square falls inside the angle made by the lines y equals to x by 2 and y equals to 3x, then a belong to. So these are the two lines over here. This is y minus x by 2 equals to 0 and this is y minus 3x equals to 0. Why I have plotted y equals to 3x over here on the upside? Because y equals to mx plus c, m is 3 over here, and if slope is higher, so basically inclination would be higher, right? So that is why y equals to 3x is on the upside and y equals to x by 2 is on the lower side. Now, given condition is a comma a square is lying between the angle made by these two lines. It's not going outside. It's coming inside this particular zone, not going outside the zone, right? Now, how to solve this? Now, what we understood in the theory was that we were trying to find out the position of a point with respect to one single line. So, but over here we have been given two lines. So, how to solve this particular question? So, let's take one point. Let's say this is 4 comma 0 over here. Now, if I try to find out the value of this particular point on this line and on this line, then I can make the comparison with respect to this particular point. Why? Let's say this line is L1 and this line is L2. In case of, let's say I put the point 4 comma 0 in line L1, I'll get some value. So over here, I'll be getting, if I put this point over here, I'll be getting 0 minus 4 by 2. And that is less than 0, right? So if I'm getting with this point, I'm getting less than 0 over here. So with this point, I should be getting greater than 0. If I plug in this point on this line, I'll be getting positive value because this value is negative. Similarly, if I plug this point in this particular line, I'll be getting some value. And since this point is also on the same side of this line as this point is on the same side of this line, right? In that case, I'll also be getting same value, same condition for this particular point as we have got for this particular point, right? So for L1, this came out to be negative, and for L2, that would be y minus 3x. Again, that would be negative. So for this, it's less than 0. For this, it's less than 0. So basically, if I plug in this point on this line, that should be positive, and if I plug in this point on this line, that should be negative, right? So we have to use these two conditions. So let's try to solve this particular point with respect to this line. So that would be a square minus a by 2, and that would be greater than 0. And if I put a square and a comma a square in this line, I'll be getting a square minus 3a, that would be less than 0. So this basically gives me a times a minus 1 by 2, greater than 0, I'll be getting a belongs to minus infinity to 0 union 1 by 2 to infinity. And for this case, I'll be getting a times a minus 3 less than 0, and that would give me a belongs to 0 to 3. So if I plot the number line, so this is 0, this is 1 by 2, this is 3. So the first condition I'm getting this one, and I'm getting this one, and in the second condition I'm getting this one and this one. So the common region is this. So a belongs to 1 by 2 to 3. So this should be the answer. So D is the correct answer. So today's lecture was till here only, and probably tomorrow would be the last lecture of straight lines, and after that we'll be starting circles. And let's meet tomorrow. Thanks for watching.